What are square numbers or perfect squares? We have some numbers here: 1, 4, 9, 16, 64, 100, 144, 169. Now, this number 1 can be written as 1 raised to the power of 2, that is 1 times 1. This is 2 raised to the power of 2, that is 2 times 2. This is 3 raised to the power of 2, that is 3 times 3. 4 raised to the power of 2, that is 4 times 4. Then 8 to the power of 2, that is 8 times 8. 10 raised to the power of 2, that is 10 times 10. 12 raised to the power of 2, that is 12 times 12. And 13 raised to the power of 2, that is 13 times 13. Now all these numbers have one thing in common. They all have been written as the multiplication of an integer with itself 2 times. Right? This is 1 times 1, 2 times 2, 3 times 3, 4 times 4, and so on and so forth. That is, if you have a number m, and if that number m can be written as n raised to the power of 2, that is n times n, then that number m is a perfect square. We are going to discuss one of the properties of perfect squares or square numbers. We have two tables here, and each table has two columns. In the first column we have numbers, and in the second column we have their squares, their respective squares. So the square of 1 is 1, of 2 is 4, of 3 is 9, so on and so forth. And same thing is here. Of 11 is 121, of 12 is 144, so on and so forth. Now, what we are going to discuss is, the property is that every perfect square or square number, will end with either 0, 1, 4, 5, 6, or 9. That is, at the units place of a perfect square, of any perfect square, if you take any perfect square, the perfect squares will end with either 0, 1, 4, 5, 6, or 9. They will not end with 2, 3, then 7 and 8. At their units place, you will not find these digits. That is, they will not end with these digits. Like, let's discuss here. So we have two tables. Now look very properly. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. You have 1 at the units place. These three are single digit numbers, so they have only units place. So they have 1, they have 4, they have 9, they have then 6, they have 5. It has 5, 6, 9, 4, 1, 0. Like, nowhere we have found 2, 3, then 7 or 8. Same thing here. 1 at the units place, we have 4 at the units place, we have 9 at the units place, we have 6 at the units place. 5, 6, 9, 4, 1, 0. Nowhere you have found 2, 3, 7 or 8. If you want to see one more table, so from 21 to 30, again 1, 4, 9, 6, 5, 6, 9, 4, 1, and here we have 0. Again, nowhere we have 2, 3, 7 or 8 at the units place. And that makes sense. Why? Suppose you have number like, let's say any number. You have 21, right? So if you have to find the square of this, 21 times 21. So the first number digit that you will multiply is at the units place, right? So 1 times 1 is 1 only. If it is 22, let's say. So if it's 22 times 22, the units place when you multiply it, you will get 4, right? There is no number which when squared with, like you multiply 2 times, you will not get 2, right? You will not get 2. Because even if it is, let's say, 1028, you have to find the square of it. So 1028 times 1028, 8 times 8 is what? Is 64. You got 4. So there are no such numbers when you multiply it with itself 2 times, you will not get 2, 3, 7 or 8 at the units place. And this is a property. So if someone asks you that whether 30187652, if someone asks you that can this number be a perfect square or square number of any number, the instant answer should be no. Just look at the units place and tell that no. Since this number contains 2, it has at its units place, it has the digit 2. So you should remember this list, that is 2, 3, 7 or 8 cannot be at the units place in the case of perfect square or square number. So this cannot be a perfect square number. Same thing, someone asks you that can you tell us that 1000896767, can this number be a perfect square or square number? First look at this digit units place and we find 7, so instantly the answer should be no, this cannot be a perfect square or square number since this contains 7 at its units place. But if someone asks that can this number 20789665, can this number be, I'm again asking, can this number be a perfect square or square number? Then you cannot tell instantly because it has now 5 at its units place, and you'll have to find out whether this is perfect square or square number or not. How to find out, we'll discuss in our later videos. So the property is your perfect square or square number will have at its units place either 0, 1, 4, 5, 6 or 9. It will not have 2, 3, 7 or 8. Two tables here, and we have in one column we have numbers, and in the second column that is opposite to it we have their squares. So the square of 1 is 1, of 2 is 4, of 3 is 9, so on and so forth, and same thing here. Right, now look at this number, that is 1, and look at this number 9. What's the square of 1? It is 1. What's the square of 9? It is 81. Now concentrate on the unit place. In this, since this is a single digit number, therefore it has only units place. So at the units place you have 1. In this case, at the units place you have 1. Now again, look at this number, that is 11, and look at this number 19. Focus on that. So the units place in this number, the square of 11 has 1 at its units place, and the square of 19 is 361. It has 1 at its units place, right? Now let's take one more table. The square of 21 is 441, and the square of 29 is 841. So 21, 29, their squares have 1 at the units place, and even in this case you have 1 at the units place. It means that if your number ends with 1 or 9, that is if your number has 1 or 9 at its units place, like in these cases 1, 9, 1, 9, 1, 9, then their perfect squares or square numbers will end with 1 only, like 1, 1, 1, 1, 1, and even in this case you have 1. So if your number, let's say your number is like some number you have here, like, and it finally ends with 1, right? Let's take some real numbers. Let's say your number is 10098 and 9. So if you're asked that the perfect square or the square number of this number, what will be at its units place? The answer will be that we don't know about the numbers, the digits at the other places, but at the units place, you are going to surely have 1. This is the units place. Same thing if your number is 9870161. What will be the digit at the units place? Your answer should be, we don't know about the other places, but at the units place you'll have 1 only. Now, if you look at this number 2 and this number 8, and if you look at their perfect squares, so this is 4 and this is 64. Similarly, in this table, if you look at 12 and if you look at 18, you have 144 and you have 324. Now, this is a single digit number, therefore it has only one place, and that is the units place. And at the units place you have 4. This is a double digit number, and at the units place you have 4. In this number, at the units place you have 4, and even in this number you have, in the perfect square, you have 4 at the units place. Now, look at all the other perfect squares in this column and in this column. You'll only find the perfect square ending with 4 in the case of numbers that are ending with either 2 or 8. In none of the other numbers you can find 4 at the units place, right? Similarly, in this table, if you look at this 22 and if you look at this 28 and their perfect squares, at the units place you have 4, and even in this case at the units place you have 4, and there are no other numbers that have 4 at their units place, right? So this is the third property, and that is the numbers that end with either 2 or 8, like these two are single digit numbers, but here you have double digit numbers, and this is also these two are also 2 digit numbers. So if your number is ending with either 2 or 8, then their perfect squares will end with 4, and no other number will have its perfect square ending with 4. So if someone asks you that on the basis of this, can you tell the next 2 perfect squares, like this is the first 2 perfect squares, this is 3rd and 4th, this is 5th and 6th, can you tell the 7th and 8th perfect squares? So the answer will be yes. If we know for 22 and 28, first it is 2 and 8, 12 and 18, 22 and 28, then you can find for 32, you can find for 32 times 32, whatever you get will be the next perfect square ending with 4, and the next one will be 38 times 38. Now I'm not going to solve it, I'm leaving this for you, right? Can you tell the next 2? Yes, 42 times 42, and whatever number you get, that will end with 4, and same thing with 48 times 48, right? Whatever number you get will end with 4, right? Now this is the importance of the perfect squares ending with 4, that it will tell you that either your number ends with 2 or your number ends with 8. And this is important when you are dealing with objective type questions. Suppose you have some number, we don't know, like let it be any number, and that ends with 4, and it's given to you that this number is actually a perfect square. This number is actually a perfect square of one of the numbers given, like here you have option A, B, C and D. So in option A your number ends with, let's say, 7. In this one your number ends with, let's say, 3, and in this one your number ends with 2, and in this one your number ends with 8, let's suppose. So this is perfect square, and it's asked you that of which number this number is a perfect square. So instantly think that this is not true, this will not be true because it's ending with 7. This is not going to be true because it's ending in 3. On these two you can try, right? Because this is ending with 2 and this is ending with 8. Therefore, since this is a perfect square ending with 4, the number has to either end with 2 or 8. Then you can find the answer from these two, right? So these two options, get excluded instantly. So this is the importance of knowing all these properties. If we look at these two numbers, that is 3 and this 7. Now, if you look at their perfect squares, since this is a single digit number, therefore it has only one place, that is the units place, and it has 9 at the units place. The perfect square of 7 is 49, and at the units place you have 9. Again, look at this 13 and then look at 17. At the units place you have 9, and at the units place, even in this case, you have 9, right? So if you look at this table, no other numbers perfect squares have 9 at their units places. Like this has 1, this has 4, this has 6, this is 5, this is 6, this is 4, this is 1, and this is 0, except these two numbers. Same thing here. No other numbers perfect squares have 9 at their units places. 1, 4, 6, 5, 6, 4, 1 and 0, except these two numbers. And what is unique in these two numbers? This number is ending with 3. It's a single digit number, but it has 3 at the units place, and this number has 7 at the units place. This number has 3 at the units place, and this number has 7 at the units place. If we want to look one more table, that is here. So this is 23 ending with 3. At the units place you have 9. This is 27 ending with 7, and it has at the units place it has 9. No other numbers perfect squares end with 9 except these two numbers. And what's the unique in these two numbers? Either like all these numbers, again ending with either 3 or 7, right? So if your perfect square or the given perfect square ends with 9, then the number whose perfect square that number is will either end with 3 or with 7, like 9, 49, 169, 289, 529, 729, right? All end with 9. So in this case, the perfect square is 23, ending with 3, ending with 7, ending with 7, ending with 3, ending with 3, ending with 7. So if someone asks you that, can you tell the next 6 perfect squares ending with 9? Then your answer will be yes. Like this is 23 and 27, like 3, 7, 13, 17, 23, 27. So you can tell, like in this case, you have 33 times 33. Whatever you get will end with 9, and then 37 times 37. Whatever number you get will end with 9, and since you have to tell 6 perfect squares, next 6 perfect squares, so the next one will be 43 times 43, and your number will end with 9. Then 47 times 47, and your number will end with 9. Then another 2 will be, the other 2's are 53 times 53 ends with 9. The next one is 57 times 57, that will end with 9, right? So this is like you can quickly tell whether what are the next perfect squares, right? So next one will be 63 times 63, and then 67 times 67. Okay. Another importance of this property, suppose in a question like objective type question, the question is like you have some perfect square and it's given that this perfect square ends with 9. This is the perfect square that's given to us. We don't know, like let's suppose, for example, perfect square. This is a perfect square And the four options are like a number ending with 5, a number ending with 6, a number ending with 7, and the D option is a number ending with 3. So if it is asked of these four options, whose perfect square this number is, so instantly reject these two options because the perfect square ends with 9. So there is no scope for the numbers ending with 5 or 6, or the only options that you should consider is either that should end with 7 or should end with 3. Now whatever number it is, on the basis of that you can find your answer, but you have, now in this case you have to focus on only two options. You have already rejected these two options that are useless for you, so that will save your time. If you look at these two numbers, that is 4 and 6, and if you look at these two numbers, 14 and 16, now this number ends with 4, this number ends with 6. They are single digit number, but they end with 4 or 6. This number ends with 4 and this number ends with 6. Now if you look at their perfect squares, this ends with 6, this ends with 6, this ends with 6, and this also ends with 6, right? Now look at another table, and if you look at 24 and 26, and at the units place in this case you have 6, and at the units place in this perfect square also you have 6. That is, the number that either ends with 4 or 6 will have its perfect square ending with 6. You have 6 here, 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 you have 6 here. Now from these three tables, right, you can find that no other numbers perfect squares end with 6 except those numbers which end with either 4 or 6. Like here you have 1, you have 4, you have 9, you have 5, you have 9, you have 4, 1, 0. 1 4 9 5 9 4 1 0, 1 4 9 5 9 4 1 0. You can find the same trend for whatever number you take, right? So if your number ends with either 4 or 6, then their perfect squares will end with 6, right? So that makes actually sense. And why? Because let's say that your number is like 936 and times 936. So of course I'm not going to multiply these. So of course the first multiplication will be of this 6 and 6. So it automatically is you are going to get 6 here. And same thing is, let's suppose you have some 1 2 3 4 5 and you have 6 digit number, and let's say it ends with 4, and same thing is here, and it also ends with 4. So first time when you will multiply, you multiply with 4, you'll get, obviously you are going to get 6 only, right, at the last digit. So that's what you can see here. Now on the basis of this, if I ask you that can you tell me the next 6 perfect squares ending with 6, so you'll say that that's very easy. First you have 4 and 6, 14 and 16, you have 24 and 26. So the next 6 will be like 34 times 34, 36 times 36, and 44 times 44, 46 times 46, 54 times 54, and 56 times 56, right? So 34 times 34, 36 times 36, this will end with 6, this will also end with 6. Then 44 times 44, this will end with 6. 46 times 46, this will also end with 6. I'm not going to calculate it, I'm leaving it for you. And then 54 times 54, this will end with 6. And then you have 56 times 56, this will also end with 6. So these are the next 6 perfect squares ending with 6. Okay, now suppose you are given any number, we don't know, a number, and that is a perfect square, and that ends with 6. This is given to you that it's a perfect square. Let's take an example, and it's an objective type question. So option A is a number ending with 3. Option B is a number ending with 7. Option C is a number ending with 4. And option D is a number ending with 6. Now, if it's asked to you that of these 4 options, which is the number whose perfect square is this number? So instantly you have to reject this one and this one, because since this perfect square ends with 6, therefore there is no scope of those numbers which do not end with 4 or 6, right? So these 2 options get rejected. Now you have to check of these 2 out of these 2, right? So you can find out on the basis of that, and that will save your time and energy both. If you look at these 3 numbers, that is 5, 15 and 25, right? So what's common in these 3 numbers? They all end in 5. That is, they have 5 at their units places. Now, if you look at their perfect squares or square numbers, the perfect square or square numbers of 5 ends in 5. That is, it has 5 at its units place. The perfect square or square number of 15 is 225. That is, it ends in 5. That is, it has 5 at its units place. The perfect square or square number of 25 is 625. That is, it ends in 5. That is, it has 5 at its units place. Now, if you look at in this column, and this column, that is a perfect squares, no other number ends in 5 except these 3 numbers, right? And what's common? They are perfect squares or square numbers of those numbers that end in 5. So what's the property? The property is that if, let's say, this is a perfect square given to you, let's say it's any number, and it ends in 5. Okay, it ends in 5, and you have 4 options. Option A is that it is a perfect square of number that ends in 2. It is a perfect square of a number that ends in 6. It's a perfect square of a number that ends in 0. It's a perfect square of a number that ends in, let's say, 5, right? So it's an objective type question, and it's given to you that this is a perfect square and it ends in 5. So you have to tell of which number from these 4 options this is a perfect square of which number, right? So instantly you have to choose this one, right? Instantly. If there is only one option that ends in 5, so you have to reject all these. But imagine that if C was not, this option C was not, it doesn't end with 0, but it ends in 5 also, that this number also ends in 5. In that case, you have to select C and D, reject these 2, and then you'll have to find that which is that number whose perfect square is that number, because now both these 2 numbers end in 5, right? So this number can also be the number whose perfect square is this number, and also this number can also be true. So you'll have to find in that case, right?